Good afternoon, everyone, and welcome to today's webinar on integrated green-grey infrastructure and green river engineering. This is a follow-up to the webinar we attempted last month, where the web platform unfortunately failed on us, and apologies to those who attended that and were let down on that occasion. I hope we have a few returning today, and thanks a lot for your patience. We will be running through the webinar today in the same fashion as we did the last time. My name is Suzanne Simmons, and I'm the Syria lead on green infrastructure and project manager for the dissemination of the two projects that we're presenting today. And this presentation is based on two NERC green infrastructure innovation funded projects. One led by University of Glasgow with University of Oxford, and the second by HR Wallingford, both having collaborated and aligned their work programmes throughout. And this webinar follows on from a seminar that we held earlier this year in April called Green Infrastructure for River, Coast and Urban Environments, that presented HR Wallingford's final outputs, Green Approaches in River Engineering, Supporting Implementation of Green Infrastructure, and that's available, both of them are available on the Syria website. At that same seminar, we presented Glasgow's interim materials on a decision framework for integrated green-grey infrastructure, the IGGIframe. So up first today, we have Jonathan Sim, who is HR Wallingford's Chief Technical Director, also incidentally Syria's new chair of our executive board, and he'll be presenting the outputs from their project, and he will then be followed by Dr. Larissa Naylor, lecturer in physical science from University of Glasgow, who will provide a presentation update on their research project. But before we start to go into the slide presentations, there's a few housekeeping notes. You're currently all on silent, so you can hear only myself and you will hear the presenters, hopefully. You can raise a hand if you have a question on the little hands up signal. But ideally, we would like to reserve the questions until the end of both presentations, unless there's something very pressing that you want to say during the webinar. You can also type up your query, and I will read it out at an appropriate time. If we do run over time with Q&As, please do make sure that you type in your question or your point, and we'll provide post-event responses from the presenters. I will share those with you if you've provided your contact details with us. So now I want to hand over to our first presenter, Jonathan Sim. So if you bear with me while I make Jonathan the presenter. And I will unmute Jonathan. Okay, Jonathan, over to you. Hello, Jonathan.
Yep, I'm here.
Good, man.
Is that? You can see my opening slide, okay?
I can see your slide fine, Jonathan. Over to you.
Okay, thank you. Well, good afternoon, everyone. This is my second attempt to make this presentation. Hopefully it will not fall over this time as I go through this presentation. So this is about the first of the two projects that Larissa was talking about, and this project is focused on river engineering protection measures. So the work that we carried out was funded by NERC under their Green Infrastructure Programme. We had a team at Wallingford which was involved myself and my colleague Marta Roca and Manuela Escaramaya, and we also had a number of other people involved, the University of Liverpool, the University of Nottingham, Syria, of course, River Restoration Centre and Environmental Policy Consulting. A key part of the way that NERC wanted these programmes to be set up, which I'm sure Larissa will mention also, was to have end user partners. The whole point of the programme was not about doing basic research, but about translation of research into usable products for end users. And we had 4 partners you see on the right hand side of the screen here. Particularly we had a lot of involvement from the Environment Agency and from Natural Resources Wales. So the the basic idea of green infrastructure is that of the network of natural, semi-natural features that intersperse and connect villages, towns and cities. And rivers are, of course, quite obviously natural corridors, although they may not be, as this first image shows, particularly green. In fact, can be rather grey if they're not appropriately dealt with. So, in fact, when we think about sort of river engineering, there is in reality a continuum from a purely natural river floodplain to something which is very grey and channelized. And between that there's a spectrum of measures indicated on the screen here, which involve perhaps moving from a completely natural environment to working with natural processes. And then before you get to traditional grey infrastructure, there's a number of green or green-grey measures that can be adopted. And the guide is really operating in this third space here on this picture. We cover a range of potential interventions which include both primarily green and green-grey. The green measures are shown on the top, and the bottom of the screen, the sort of slightly darker green, grey-green, are measures that involve a combination of hard measures or traditional engineering, whether that be fabrics or geotextiles or some other, even in some cases rock, combined with green engineering. And then in some cases we need to actually give some information about the geotextiles and rock rolls as well. In addition to that, there's the more what I would call whole reach measures that are part of the kind of interventions you might carry out, which are listed here: embankment removal, meander restoration, lowering of weirs and culverts, and changing channel dimensions and so on. And of course the whole point of this is that in practice solutions tend to be a mixture of these different types of intervention. So in the kind of constraints that we're often working within in practice, you can really have something which is completely green, but you can introduce significant green measures into it. But one of the questions you may be asking is, well, a lot of this stuff seems to have been around in some form or other for a long time. Why isn't it being more widely used? It's often used in river restoration contexts, but not perhaps in situations where people are actually worried about flood risk and the effectiveness of such measures in situations where we're trying to deal with flood risk and might traditionally have used grey measures. Some of the barriers that we identified with the Environment Agency and Natural Resources Wales were these that are listed on the screen at the moment, so that people don't think about they don't think about multifunctionality. Perhaps there's this perception that these measures may have a higher risk of failure. They don't feel there's the evidence to support their decisions. There aren't performance-based assessments. There's basically either a lack of information or a perception of a lack of information and a lack of confidence. And this was really, from the Environment Agency and Natural Resources Wales perspective, one of the key drivers behind going ahead with this or supporting this work. So what were the objectives? So the objectives were to do two things, or three things here are listed: to develop a decision support framework, to identify critical success factors and produce a repository of fact sheets. We didn't say initially that we would produce a guidance document, although what happened in practice was that we ended up putting this all together into a document which is in fact available from our website and from Sylvia's website, and you will get the link to that at the end. So I'm just going to go through each of the, how we dealt with each of these elements. So the first thing to say about the decision support framework is that we tried to work with Dr. Naylor at Glasgow and her project, the IGGI project, to make sure that the decision support framework was as consistent as possible. Certainly at the upper level here, which you see we are seeing this operating at both the business case level and also at a technical level. Companies are looking at opportunities and consequences, appraising options, and then going through the traditional decision-making process, and then finally doing some monitoring evaluation. And I'm going to step you through some of the components of this framework cycle, both at the business case level and at the technical level. So starting with the business case level, we were very mindful of the Treasury guidance on making a business case, which covers these so-called 5 cases here, the strategic, economic, commercial, financial and management cases. And that's like standard stuff now when a public project is going forward. And we tried to reflect that in the way that we gave information. And then going through the project, then the guidance, we tried to focus the guidance to make sure that we were covering stuff that wasn't covered elsewhere in standard guidance. A key element in the first step is understanding the type of river. There was some good work that had already been done on this, so we've not tried to reproduce that particular element of guidance. To change that piece of guidance, but we've just reflected that in the in picking up on an existing flow diagram here, which is shown on the right-hand side of the screen, just to identify the type of river, asking questions about the amount of reinforcement, the type of sedimentation, the type of features in relation to the floodplain and so on. The second step, opportunities and consequences. Clearly here we can imagine that there are many guidance documents that we can work within. There are policy documents such as those listed here, and also statutory requirements to actually try to move towards a greener world. And then we can think about identifying and appraising the options, and here a fundamental cornerstone of our approach is this idea of going back to the spectrum that I showed you earlier on in the presentation, to think instead of starting on the right-hand side of this diagram with the grey infrastructure immediately, we start on the left-hand side of the diagram, thinking sequentially through the options that are available to us, but always working from the basis that you start as green as possible. And of course we set this out as the framework, but of course the guide that we've produced and the information is focused mostly on the green and the green-grey. So within thinking continuing to think at the business case framework level, the higher level, then the critical success factors that emerge at that level are clearly people have got to be motivated towards wanting to include green infrastructure in their project. They've got to be satisfied about engineering performance. And here we provided some simple guidance about the fact that that there are different velocity regimes specifically in which these different measures can operate. And although these are kind of rules of thumb, there's an indication that green-grey green can operate up to about 1.5 meters per second, and green grey can possibly operate up to about 4 meters per second flow velocity. And that's a pretty substantial coverage of the range of situations that you would experience in streams and rivers. Another critical success factor at the business case framework level was being able to demonstrate that there were additional benefits that would accrue if green infrastructure was used, and some of these are listed in this matrix here, things like wildlife access, greater habitat complexity, being able to provide shade and cover, and then the effects of the vegetation in terms of pollutant removal and sediment capture and so on. And then, of course, as in any business case framework, there's the need to discuss costs and risks. We now move down to the lower level. The technical support framework here is what I'm now going to deal with, and again step you through each element of the cycle here. So if we think about the drivers of the change in the project objectives, first of all, here there are various factors that might influence why you want to do some kind of green infrastructure. In this case, we're showing as an example the need for bank stabilization, and we discussed in the guide the reasons why bank instability might be a problem. And then we look at, in terms of the identification and the appraisal of the options, we provide some flow charts to enable people to look at the various things that are available to them in a simplified decision sequence that takes you through the various options that are available, taking account of factors such as bank, the steepness of the bank, the amount of sediment transport, the amount of space available, and so on. And then if we move to the issue of the success factors, here we've got a much longer list of success factors that we identified, which are listed here on the slide. And for each of these, we provide a description of what the issue is, what you're trying to achieve, and then some recommendations and tips for how to address that particular issue. When we ran a workshop as part of the River Restoration Conference about 18 months ago, we had very interesting feedback from the people that had been involved in green infrastructure measures in streams and mainly in river restoration projects. And they pretty much identified all of these factors, with the exception of the filters. It seems like it's an issue that hadn't, in many of the ad hoc applications of GI measures, filters was one of the issues that had not been adequately addressed, and failure of filters had been possibly a significant issue as to why projects had maybe not succeeded as well as possible, and even possibly in some cases got a bad name. And then a final component of the study is the case studies. So this map here shows the different locations of the case studies. We weren't focusing so much on trying to get an even geographical spread across the country as trying to make sure that we got most of the types of river watercourse shown included within our within the case study group. So the way that this is written up, in a way that's broadly consistent with the way that Larissa will present in a minute, was to have a sort of consistent framework and a series of elements that would be consistent across each case study. So an initial box indicating as to how successful the scheme had been. So if we blow that up, it's just summarising in terms of engineering performance, inspection and maintenance, costs and additional benefits, effectively giving a sort of a high, medium, low scoring for each of those. Then information on site characteristics and motivation, costs, and then importantly additional benefits. So we give here a benefits wheel, which is consistent with the approach that the Environment Agency is using in their working with natural processes research, looking at not just the flood risk reduction benefits, but also aesthetics, cultural, water quality aspects, habitat, climate regulation, the ability to work with low flows, and health and air quality aspects. So this brings me more or less to the end of my presentation. Just draw to your attention again that the output is available either from our own website, which is listed here, or from the Syria website. I think Suzanne will give you a link at the end of the project. We're pretty happy with the outcome. The printed version of this booklet has been distributed widely within the Environment Agency, and we had a second order come back to us, so we're quite confident that it's providing the information at a level which is both attractive but also gives enough information to get people moving in terms of using infrastructure on their river projects. So thank you for your attention. I think we'll take questions later on.
Hi Jonathan, thank you so much for that. There's quite a lot of background noise, everyone, and sorry about that. I think, Jonathan, you must be in an open plan situation. There's a few people were commenting on it, but unfortunately we have to work with where we are. I'm going to just make myself presenter. Okay, just bear with me. Okay, thanks, Jonathan. And I will now.
Well, if you have chosen that sound ready,
okay, so I'm going to hand you over now to Larissa Naylor. Sorry about the background noise. Unfortunately, we can't always choose where we're able to give our presentations from, and sometimes we just have to make do with open plan offices. That's where we all are based from time to time. Larissa, I will just make you presenter now and hand it over to Larissa Naylor. Just bear with me. Go unmute. Hello, Larissa. Hello, Larissa. Can we hear you?
Yes, you can hear me. Can you?
I'll hand over to you now.
Okay, great. So welcome everyone to the webinar, and hopefully the second half of the webinar will work today. As unfortunately it crashed in October when we tried to deliver it the first time. So thank you again for your patience with this. My name is Larissa Naylor. I work at the University of Glasgow, and I am here today to talk to you about our project, which is a sister project to Jonathan's river project from HR Wallingford. We've called this project a decision framework for integrated green-grey infrastructure, and I'll unpack that as I go through the presentation. And please, if you have any questions, make sure that you add them into the question section, but also feel free to tweet about the webinar with that hashtag #greeningthegrey. That would be much appreciated. So today I'm going to talk to you about what we mean by greening the grey, sorry, I'm having slight technical glitches because the webinar screen covers up my presentation. And we're going to talk about why is it needed, and how we can get Greening the Grey approved in your schemes, and then talk through the specifics of my project that I worked on with a team of people from around the UK, with a lot of input from academic and practitioners as well. So why do we need green-grey, integrated green-grey infrastructure, and what is it? And so a lot of green infrastructure policies take a look at the top half of the diagram. So I'll talk about greening of natural spaces, terrestrial spaces primarily, a little bit of blue spaces, and a little bit of reference to buildings. Whereas green-grey infrastructure is about greening of assets that have to remain primarily grey beyond buildings, so these non-building assets. So as you can see in the bottom half of the diagram, there's a lot of information that you could, a lot of places that you could green that aren't currently part of green infrastructure policy. And our project designs to address this gap, both at a kind of strategic level, but also at a practical level for practitioners. So it's drawing together examples from a range of sectors that have been done as innovations or research projects, and bringing them together into a cohesive framework. And so you can think about green infrastructure as a continuum from grey to green infrastructure. And the main thing to note here is this integrated green-grey infrastructure sits in the middle. So greening the grey is about these areas that have to remain primarily grey. And often, as you'll see below, you've got some pictures of some people walking along a slipway, and you've got a round brick amongst rectangular bricks. Those are examples of greening the grey specifically for animals. So often these examples aren't necessarily very green looking because they're providing habitat for animals rather than greenery per se. And if you can think about it in terms of flood risk planning and discussions at the moment, so the Environment Agency talks a lot about working with natural processes, so the WWNP, and so this enhancing hard engineering is another way of framing greening the grey, between working with natural processes and traditional engineering. And so in terms of how we can then create integrated green-grey infrastructure, I think one of the novel things about this and practical things about greening the grey is it can be done in a multitude of ways at a multitude of project stages. So you don't just have to think about it strategically as part of big planning operations. So at the bottom, you talk about being strategic. So the Crown Estate has their Wild West program in central London, and that came out of the London Ecology Master Plan. So that's an example of a strategic level where you might be thinking about greening the grey. But it can flip to the other end of the spectrum. You could be talking about temporary features. So you talk about green hoardings rather than plywood hoardings when you're building at a construction site, for example. And things can also be retrofit onto pre-existing structures, and they can be done as part of maintenance, or they can be designed in as part of new schemes. And so people do this enhancement for a range of reasons. They look at doing it for, they look at doing these enhancements for ecological gain. So they target species of concern to comply with legislation. And you can do it in a very active way, such as all of these photos about adding features to the landscape, or you can do it in a more passive way through material choice, although the ecological gains may not be as high as if you do it in an active format. But primarily a lot of these have been done for ecological gains. But they've also been done to improve asset resilience. So deterioration of coastal structures, but also historic ruins and other features in the urban environment is a high cost. And so can you actually use some of the biology to help improve asset resilience? And there's examples in our project that talk about both of those things. And so the overall objective of the IGGIframe project was to broaden the range of GI tools. So there's this policy gap, and there's work that's being done by academics and practitioners in different sectors, not particularly aligned with green infrastructure, that can draw in examples that may be useful for green infrastructure practitioners. And the goal was really to provide some evidence-based case studies to boost the evidence for greening the grey, and to create a simple framework so that people like yourselves can think about how to improve uptake of greening the grey as part of existing or new hard assets. And this can be done by comparing business as usual against a series of metrics, the same metrics that Jonathan talked about in terms of critical success factors, against the green-grey option. And so why did this project come about? We had a precursor project that was funded by the Engineering and Physical Sciences Research Council, and as part of that we interviewed 53 practitioners, and we asked them what do they need to move from innovation to wider implementation around greening the grey, and overwhelmingly they felt that they needed guidance, they wanted evidence of the effects on the assets, they wanted details on costs, and some of them wanted comparison tools in a business case. And so we set up the project. It was funded with a suite of project partners, project supporters, an advisory board, and a series of sub-consultants. As this project was academic-led, the sub-consultants were important in providing kind of industrial application and making sure that we were consistent with that. And so as far as the outputs of our project, there's the decision support framework, which will be a front-end report that outlines, why we did what we did, what is greening the grey, and that involves a method by which you could assess your own green-grey options against business as usual. Originally, we said we'd have 10 case studies. We've actually developed many more than that, and we have a series of art of the possible examples as well, which are smaller vignettes than the case studies themselves. And so we cover a range of environments from coastal and estuarine through historic environments, the urban environment, and we've pulled out a few cost-cutting examples. So mowing for pollinators could be done across this landscape. And there's a range of measures. So as I said before in the diagram, the three-dimensional diagram, that we're looking at greening of non-building grey assets. But as in some of these examples, you've actually got park benches that are designed for bees as well as people. We've got bricks that are designed to house solitary bees, to provide pollinators. You have a green bridge, and you have retrofit rock pools going on seawalls. And these are some of the examples of arts of the possible, where they talk about some of the benefits that have been realized through adopting green-grey approaches. And there's some of our examples who have multifunctional benefits, so benefits for air pollution as well as biodiversity, as well as some water attenuation or asset resilience. And so the top picture is a green screen that was tested in Birmingham using ivy on a guardrail to look at absorption of particulates, particularly pressing for air pollution. And the bottom is a structurally engineered salt marsh in the Thames, and which is providing habitat for fish and an improved immunity value. And so similarly to Jonathan's project, we came up with an agreed set of critical success factors between the two projects, between all of the different project partners and supporters. Say, if you wanted to get green-grey approved, what would we need to know? And so we would need to know why should we do it? So is there a policy motivation? Is there a reputational motivation to these projects? How do the costs compare to business as usual? This is a key element of our project that differs slightly from Jonathan's. So we tried, wherever the costs were available, to compare the benefits of the greening against the costs of construction against a business as usual grey solution. And there was a big query a lot of times, does the greening affect performance positively or negatively? And that question was addressed as part of our information gathering, and that social value was assessed where there were data available, as long with ecosystem services and asset resilience to form these critical success factors. And so we developed a decision framework and an iterative process by building the case studies and gathering the data. Each case study is assessed against all of those primary and secondary critical success factors, and we set criteria to differentiate between the case studies and the art of the possible. So the case studies are more data rich and have good data, quantitative data comparing certain metrics such as the ecosystem services provided or aspects of those, and also they needed to be operationally applied rather than just purely from the research base, and that was a requirement of the project partners. So the arts of the possible tends to be those examples either where there wasn't a huge amount of data against certain metrics, or they were done in a very rigorous way by academics, but only for certain parts of the project, and they've been done as tests rather than as operational applications. We assessed each of these critical success factors against business as usual to produce a cost benefit where against business as usual. And so it's a sort of step-by-step guide through each of these parameters. So the benefit was based on is basically the overall summary of a case study and its value, looking at the costs and benefits and to assess the net value. It was qualitative to semi-quantitative depending on the data, and it can be thought of as the overall assessment of these critical success factors. And then the engineering element was looking at an operational assessment or expert judgment assessment of the positive or negative effects on asset performance, inspection and maintenance as well, and asset resilience. And importantly, none of the measures appear to adversely affect engineering performance, inspection or maintenance, and some improve asset resilience. So there can be a net positive from doing the green-grey compared to the grey in terms of engineering. And just as a point of reference, you've seen some icons popping up and some color coding. That was developed because the project partner said, we want to make sure that we can access the information we want quickly, and we want different people within our organization. So we want the engineers to find what they want quickly. We want somebody who's interested in ecosystem services to find what they want quickly. So that whole color coding and iconography flows throughout the project to help you access the information. And so the ecosystem services, again, are a combination of qualitative and quantitative data, and they're calculated where there's quantitative data comparing them against the business as usual. And most studies only measured some services. So how much habitat was provided, how much biodiversity, how many pollinating species, that sort of thing. And there are some data gaps. So there's very little information on whether these greening actually helps regulate, say, attenuate waves, for example, at the coast, or in terms of the cultural benefits that they provide. And the costs have been calculated based on the capex costs of the greening compared to business as usual, because the TOTEX costs capex costs have been hard enough to get hold of in a lot of cases, but the TOTEX costs are referred to in terms of the long-term costs, so we try to take account of those as well in the case studies. And they're summarized as being the less, the same, or more, and with cost details as common metrics that are used in industry standards or government standards to generate costs. And we worked with our partners to identify which costs they wanted us to use for business as usual. And in terms of the social data, we looked at social benefits, and sometimes that was a driver for the work. So social cohesion was often a driver for getting funding to deliver some of these green-grey solutions. And we looked at reputational benefits and whether there was a policy motivated for the work. And importantly, one of the things we added was a data quality element. So for each group of metrics, so cost, engineering, and ecosystem services, it says environmental, the cost was, the data quality was assessed against the scheme-specific information, expert judgment, and wider supporting evidence. And on the right, you can see the front page of one of the case studies, and that format is consistent throughout. And so for each of the thematic areas, so for the coast, urban, historic, and mowing, there's a business case, which you can just see the front page of the coastal one there, that basically talks about what are these measures, where have they been applied, what environmental conditions do they work in, and how might you aggregate some of the individual measures into solutions, what are the known risks, and importantly, how can I get approval? And so that's done at a high level for each topic, followed by a series of case studies and art of the possible examples. And so this is a business case for mowing for pollinators. You get a flavor for it. And so there's an overall benefits assessment where all of the examples are aggregated. And so this benefits assessment, there's a wheel, and that is consistent in design and approach to the HR Wallingford project, but also to the Environment Agency's Working with Natural Processes Evidence Directory, which has just been released. And then we talk about which measures. Again, that language is comparable to Jonathan's project, so the IGI measures are individual things you could do, whereas solutions are how you put them together. And the nice thing about our project is you could actually look at solutions that could run across your urban planning, for example. So you've got an estuarine or coastal city where you could be looking at some coastal and estuarine IGGI, followed by some historic assets as well as the normal built fabric. And you could look at grading the grey across all of those, including into the rivers, and bring in some stuff from Jonathan's project. And so this is a page I'm going through this business case for mowing. For those, there's no limitations or risks. And then on the right-hand side is an example of the art of the possible. And in this case, they saved a light industrial unit owner money on annual maintenance of mowing grass and clipping hedges by turning it over to a social enterprise and allowing them to create urban grassland and a tree nursery that became self-financing, which then produced some income and some jobs and reduced carbon locally through capture from the trees that had been planted, but also saved the asset owner money on their annual maintenance charges. And so at the coast, we have a series of case studies. This is the most voluminous of the project, because the Environment Agency was very keen for this element to be comparable to the Rivers project. So there's a series of coastal case studies, and some of these are some front page of some of them. So you're looking at how can you use rock armor, how can we choose different rock materials, position it differently. There's art of the possible examples about how you actively enhance that through the provision of holes, or how do we alter our coastal walls so that we can add more homes for animals and plants, algae. And here's an example that's in here from Seattle, where they've actually had a large research project that underpinned to say, what do we need to produce habitat for food that salmon eat? And so when they're redoing their seawalls, they decided to create amenity space, such as this walkway, but all of those rectangular panels that are within the walkway are actually light vents designed to provide light to the subtitle to improve the habitat provision of food that salmon eat. And as you can see, it was a very small percentage of the cost. It was less than 1% of the cost of the overall project. And so at the coast, we have these series of art of the possible examples. They're less data rich. They tend to be research, but they can also be operational. And they're really to showcase ideas and to give you a sense of what is possible. So we have things like using old sheet piling, cutting it down and using it as the toe to create intertidal mudflat in a very confined estuary, built estuary in Cornwall. You can look at adding rock pools to existing sea defences, or this on the right is testing textured concrete with a view to those being prototypes for formwork that you would use for whole walls. And so you can combine these into solutions, and you can also look at where they may be suitable within the environment. So what is the sediment loadings that they've been tested in, and what is the wave exposure and tidal heights that they've been tested in to help practitioners. And so this project is nearly completed. We're still waiting for some cost data from some of the partners on the urban bundle, and William Alsop from HR Wallingford has just finished his expert judgment assessment of the coastal bundle, and the historic bundle is out for comment with Historic Environment Scotland and Historic England, and the mowing bundle is completed. So it's all very close to being finalised, and it will launch in December, and we would welcome any feedback on it, but also if people want us to give further webinars and things like that, we'd be delighted to do that, because we've won follow-on funding for the project, which will start in May 2018 and run for 12 months, and that the whole purpose of that is to help embed it in organizations such as yourselves. So thank you very much for listening today, and we hope you have some questions.
Thank you so much, Larissa. That was really interesting. Hope everybody managed to hear everything okay. We will be sharing both presentations on the CIRIA website later, and as well as any updates provided, and we'll pass them on to the CIRIA web page to everyone who has been involved in the webinar today and who's attended the webinar. I'll now hand over, if anybody has any questions, you can use the hands up facility, and I'll just move on forward. Oops. Yeah. And I'll just unmute both Jonathan and Larissa. There aren't any questions that have been raised yet. Just check for any hands up. No hands up, no questions. There's a little hand up here, so what I'll do is, it's from John Dobson. Hi John, I'll unmute you, and if you want to say hi and say where you're from, and ask your question. Hello John Dobson, can you hear me? Hello? John Dobson, you've been unmuted. You had your hands up. Okay, well, John hasn't answered, but there is a question that has come through from Neil McLean. Hi, Neil. It says, hi, Larissa. How resistant is the greening of hard surfaces to erosion? For example, high energy river and or wave actions. So, Larissa, maybe you could answer that question for Neil McLean.
Yes, hi Neil. I can talk to the coastal context rather than the river context. It depends on the species that you're looking at. There's one out of the possible example which looks at barnacle and seaweed bioprotection, and barnacles can be in quite wave-exposed environments, but they would be both of those things may be. The research shows that they are helping mediate some of the weathering-related effects of deterioration of assets. So that's things like thermal expansion and contraction, and reduce of sort of granular disintegration that will create cracks that can then be exploited by waves, or reduce the risk of chloride ingress into structures, which then in turn damage the structure. So Japanese researchers have found a 1,000-fold decrease in chloride under covers of barnacles compared to places where there's no barnacles, in a study in Japan. So they're not necessarily going to mediate the risk of waves. And in the estuarine example in the Thames, the salt marshes are up to 9 meters in width, but there are actually no data on that regulating surface. So we don't know whether that marsh is actually providing any benefit to the sheep piling that it fronts, for example, in terms of resilience. But we do know it provides habitat for fish.
Okay, thanks, Larissa. There's another question. There's a couple of questions lined up. Neil has said, great, thank you. We've got one from Robbie Soetanto, who's asking, have you had examples of the use of green infrastructure to protect, improve resilience of infrastructure along river channels, for example, bridge foundations? So I'll pass that question on to Jonathan, and Larissa, if you want to chip in after, just let it know. Hi, Jonathan. Are you able to answer that question for Robbie? Hi, Jonathan.
Yes, hello.
Yeah, if you want
I think it's a question, Robbie, of hello? Yes, I'm here.
Yeah, we can hear you.
Yes, okay. I can't quote you a specific example of around a bridge foundation, but the whole point of the philosophy of guidance, which was to identify where different measures work within different velocity ranges, and so I think that's the approach you've got to take in this situation. And if you've got significant velocities, it's pretty much always a combination of grey with green, picking up on the point that Larissa was making in response to the previous question, I think if you've got significant velocities in rivers, then you have to have this kind of combination.
Okay, Larissa, do you have any response for that? Is there anything you want to add at this point?
Not especially, but I would say that some of the bioprotection effects have been less studied by certain fields within river systems. So I come from the geomorphology community, biogeomorphology community, and there's been some work done. There's been more work done at the coast about those interactions than in river systems themselves. Other than, say, banks, there's been more work done on, say, bank stabilization and things like that, rather than the harder structures in rivers and how we might use some biology to help manage the asset resilience of those structures. So some of it is a bit unknown, I think.
Okay. Thank you. There is a hands up from Stephen Dunthorne. Unfortunately, Stephen, you are muted and we can't unmute you. And I wonder if it would be possible for you to put a question through to us by typing it up on the question pane. Here it is. Oh, here, you've just added one in. So Stephen Dunthorne has said, what did the project take to be as business as usual? Now, I'm not sure if that question is for either Larissa or Jonathan. Larissa, are you able to answer that?
Yes, I can. Jonathan, the business as, or Steve Dunthorne, the business as usual varied by example. We worked with practitioners or researchers to say what was the alternative you were comparing it to. So, for example, one of the mowing case study, earth embankment, flood defences, the terrestrial side was mowed quite frequently previously, and what they did is they did a trial reducing the mowing frequency without affecting any engineering performance because it's still mown once a year, and looked at the impacts on ecology. So in that case, you could actually compare the costs of the conventional maintenance regime compared to the altered maintenance regime, which was much cheaper in that example. Where it was things like coastal structures, hard structures, we got Environment Agency costs, and we were required to use those costs to compare against the greenings intervention that was put in place. With historic environment examples, those were by working with either the universities doing the research and the government agencies, or with the government agencies themselves, about getting costs. And in one case, a quantity surveyor provided the costs of the two different alternatives, and in that case it was 82% cheaper to use the soft capping compared to the hard capping.
Good stuff. And I'll just ask Jonathan, did you have a business as usual case scenario, Jonathan?
Well, so it's difficult to frame it in exactly those terms. The way I would see it is that you've got in a river engineering situation, you're often trying to manage a situation where there's instability, which, because of the human constraints around that particular reach of the river, you're trying to constrain in some way, and so therefore it may, business as usual would, I suppose, be get something close to doing nothing, but that might not be acceptable. I think if you're asking a separate question, which is comparing a grey intervention in comparison with a green intervention, I think a lot of the measures that we discuss in the guide are pretty cost effective.
Okay, thank you, Jonathan. I'm just checking to see if there are any other questions. No further questions appear to have come up. We've had thanks from Robbie and Neil for responses. And I can't see anybody with any more hands up. Oh, let me see. No, there's no other hands up for questions that we haven't already answered. So I think at this point we can say thank you very much for everyone for tuning in this afternoon. I think you'll agree they're two very exciting projects with many future applications. I'll just hand over to Larissa and Jonathan one more time. If there's anything further that they want to say, I'll hand over first of all to you, Larissa. Is there anything further you want to add before we close off the session?
Just to say thank you very much for listening this afternoon. If you have any further questions, do please get in touch. But also, if you'd like us to help share the information coming out of our project in more detail with your organization, or you can think of ways you might be able to apply it, again, we'd be delighted to speak with you, because we will have a kind of a follow-on project from next May that's designed to help embed this within organizations and see how you're using it to help refine it, but also to see how useful it is. Many thanks.
Okay, thank you, Larissa. And same to you, Jonathan. Is there anything further that you want to add before we close this session?
No, just to remind people that they can get our guidance document from your website and from our own website. And also just, I think Larissa mentioned that she had a workshop scheduled at the Institution of Civil Engineers in December. I don't know whether you could provide on the website details of how people can access that.
Well, we would love to do that, yes. Yes, if Larissa can share that information with us, then we'd be more than happy to put that link on the website.
Jonathan, I don't know where you got that. There's nothing planned for December, but what we will do is, as soon as our project is launched on Syria, I will then arrange for Suzanne to circulate that to everybody who signed up to both webinars.
Okay, all right. I thought I saw some.
Yeah, we will do that. But thank you both very much. And if there's any updates, please do check out the Syria website. And I've just got a page here that shows you links to our future programs, links to where you'll find material on the two projects. And also there's a project that we've just released, the scoping study for delivering green infrastructure along linear assets, which starts a longer term project, we hope, within Syria. So if you're interested in becoming involved in that, do get in contact with me. I'm the project manager for that. I'd like to thank you all very much for joining us today, and we look forward to hopefully being able to provide you with more information. Do leave your contact details with us, or get in touch with us if there's anything further that you need to know. Thank you very much.